Hi folks, my name is Silin, coming from the Natural Language Processing Lab at EPFL University. Now I'm going to introduce our work of ComFact, a benchmark for linking contextual common sense knowledge, collaborated with Allen Institute for AI and Sony Group Corporation. In conversations, stories, and other varieties of natural language contexts, language users often elide information that listeners or readers reliably fill in with word knowledge. For example, in this picture, the pink speaker infers that the blue speaker wants to be a doctor because he's studying medicine, even if the blue speaker does not explicitly mention his career goals. To reflect this ability, natural language processing systems are often augmented with common sense knowledge graphs to acquire such background knowledge, which is represented as triples of facts as shown in the picture. Currently, many researchers have been working on constructing high-quality, large-scale common sense knowledge graphs, while others focusing on developing downstream applications such as dialogue systems that can reason over such common sense facts to get better performance. However, the intermediate retrieval of relevant facts, in other words, common sense fact linking, what we are going to investigate, is underexplored, which, however, plays an important role in bridging common sense knowledge graphs with downstream tasks. In this work, we are going to investigate how do we reliably retrieve common sense facts that are relevant to natural language contexts. This is an important question since it has been shown that imprecise fact retrieval is a key contributor to the spurious reasoning abilities learned by NLP systems. To make a precise fact retrieval, we need to first find out what makes a fact truly relevant to a natural language context. Here, we detect a contextualization challenge, where the facts that we truly want are those relevant to the situation described in the context, rather than just related to some mentioned entities. For instance, here, X writes a book to tell stories is fit into the situation of the dialogue shown here, but X needs to know about how to write before writing books is just generically related to the action of writing and has nothing to do with the plot of this dialogue. We also detect an implicitness challenge, where common sense facts are often relevant to the context in implicit ways. For example, book used for learning about medicine is easy to be linked to the context since it has an explicit reference medical books. However, X needs to go to college before he treats patients is implicitly related to studying medicine and being a doctor, and no explicit reference poses difficulties in retrieving this fact. This indicates that simple surface form matching may not be enough to retrieve a relatively complete set of common sense facts, so more advanced fact linking techniques should be developed. To more adequately address these challenges, we construct a common sense fact linking dataset ComFact to benchmark the next generation of models designed to improve common sense fact retrieval, where we first sample natural language contexts from 4 diverse dialogue and storytelling corpora, including personal chat, Mewtwo, rock stories, and CMU movie summary. Then we link facts to each sampled context from Atomic 2020, which is an advanced common sense knowledge graph covering rich knowledge types about physical entities, daily events, and social interactions. For the fact linking process, we adopt widely used heuristic methods to first oversample a set of fact candidates that are potentially relevant to each context. And facing the challenge of implicitness, we use not only the surface form pattern matching, but also the implicit dense retrieval method to conduct such oversampling. Finally, we conduct human validation to let cross-source workers judge whether each linked fact candidate is truly relevant to the context, resulting in about 293,000 contextual relevance annotations being recorded in our dataset. Here we show an example of our data construction for the initial context about studying medicine and writing books, where a list of fact candidates is retrieved by the heuristics in the first step, such as X write books because X wants to tell stories, and then all the fact candidates are fed into the human validation to get their relevance annotations. For example, book used for learning about medicine is contextually relevant, while book used for put on the shelf is not relevant to the dialogue. To check the effectiveness of heuristic fact linking, which are widely used in previous research for knowledge retrieval, we conduct analysis on our ComFact dataset. And to count the numbers of fact candidates that are annotated as relevant versus irrelevant. The analysis is done in a fine-grained way, where we stratify our results based on different heuristics that we use for oversampling candidates, including explicit pattern matching and implicit dense retrieval. Here we show the analysis on raw atomic data portion for an illustration. So for each stratified results, we get thousands of relevant facts, but also a larger proportion of irrelevant facts at the same time. This indicates that unsupervised heuristics actually, whether based on explicit patterns or implicit embeddings, often link irrelevant facts, which are imprecise knowledge retrievers. We also find that facts retrieved by implicit heuristics are more likely to be relevant. This shows that adding implicit retrieval beyond surface form is valuable in recovering a rich set of relevant facts. Otherwise, nearly 7,000 of relevant facts will be ignored at the first step. Here we list the analysis results on all 4 ComFact data portions, where we observe similar patterns across different portions. We posit that such imprecise fact linking by heuristic will introduce noise to any resulting extracted knowledge representation. So how can we improve that? One direct idea is to let neural models to learn from our human annotations about relevance. In other words, would neural fact linkers trained on ComFact retrieve more relevant knowledge? To explore this point, we fit language models with pairs of context and fact candidates in our datasets and train them to classify whether each fact candidate is relevant or irrelevant to its context. And this table shows our split of training, validation, and testing size on our 4 ComFact data portions, and models are trained and tested on each data portion individually. Here we show the fact linking results averaged on the 4 data portions. We test various language models including LSTM, BERT and its distilled version, Roberta and DBERTA, and compare them with the best heuristics, which is explicit pattern matching and also the human performance. From the results, we can see that neural fact linkers learned on ComFact get across-the-board improvements over the heuristic method, which is in average about 34% of F1 boost. However, our trained fact linkers still have considerable room for improvement compared to the human, showing that ComFact is actually a promising testbed for developing better fact linkers that benefit Commonsense augmented natural language processing systems. However, as new corpora and knowledge bases keep popping up, it is impossible to annotate or update Commonsense fact links for every newly appeared resources, so we need to face the question of whether our developed fact linkers can adapt to new types of context and knowledge. To first check out our fact linkers' ability of adapting to new contexts, we conduct a cross-source generalization experiment, where we train and test our Roberta large fact linker on the combinations of training and testing sets across different ComFact data portions. As shown here, we find that models trained on the first 3 data portions, where contexts are built in artificial ways, all have difficulties in adapting to the 4th movie atomic data portion, where contexts are sampled from real world. This shows that maybe fact linkers trained on artificial built contexts still have a large room for improvement on adapting to real world contexts, which are often maybe longer and more complex. By contrast, the model trained on real contexts from movie atomic generalizes well to other data portions. And all these results indicate that ComFact is also a promising testbed for developing more scalable fact linkers. In terms of our fact linkers' ability of adapting to new knowledge, although there should be more research done in the future, we note that the knowledge graph in ComFact that we use for training contains rich types of knowledge across physical, event-based, and social aspects. This makes our developed fact linkers have larger potential of generalizing to other common sense knowledge graphs, such as widely used ConceptNet, which contains many physical relations. We also test the stratified performance of a Roberta large fact linker on different types of knowledge subsets and find that it performs well on linking the physical knowledge, which supports our claim here. Finally, it is also important to explore whether we can use better fact linkers to improve downstream tasks. For this, we investigate a downstream dialogue generation task using the implicit dialogues dataset and choose the CEM model developed on this dataset as our target of improvement. This model first uses Comet, a common-sense knowledge generator, to generate facts related to the dialogue context, and then uses another module to generate implicit response to a context with the help of prior generated knowledge. However, the generated knowledge may have contextually irrelevant facts that mislead the response generation. So we use a deburter large fact linker trained on ComFact to filter the generated knowledge, and we suppose that the refined knowledge will improve the quality of response generation. Note that the downstream dataset is beyond the coverage of ComFact's corpus, and the generated knowledge from Comet is also beyond the coverage of ComFact's knowledge graph, so improving such downstream tasks is challenging for fact linkers since it involves out-of-domain context and knowledge. This figure shows the relative improvements of the CEM model by using our developed fact linker, where we can see that ComFact linker brings considerable improvements across a wide range of metrics for evaluating dialogue generation. In average, ComFact linkers brings about 9.8% of relative improvement on the response generation scores. This shows that our fact linker can help retrieve more contextually relevant common sense knowledge, which finally improves downstream task performance. In summary, we find that widely used heuristic knowledge linking methods often retrieve many irrelevant facts, and to improve common sense knowledge retrieval, we propose a new challenging benchmark ComFact, which contains about 293,000 contextual relevance annotations. Fact linkers trained on our benchmark achieves about 34% of absolute FM boost over heuristics, and also yields about 9.8% of relative improvement on a downstream dialogue generation task. Our paper and code for this work are public now.